In Theorem 6-12, what we're going to look at, instead of looking at properties of rhombuses and rectangles, we're going to look at what must be true for a parallelogram or a quadrilateral, if it's a little bit more general, to be a rhombus or a rectangle. So how are we going to prove that this quadrilateral or parallelogram is special and that it has a special property like being a rhombus or a rectangle or both, which is a square? So it says we are taking a look. Our shape is ultimately going to be a rhombus, that we're told that. We're just going to try to prove this. And so we have this parallelogram ABCD. That's our given, right? We're given that ABCD is a parallelogram. And then we're also given that one of the diagonal bisects two of the angles. And so we're given that BD bisects angle ABC and angle ADC. So make sure you're paying close attention and noting that what we're doing here is not proving the theorems about things we know are rhombuses and rectangles, but we're trying to show what criteria has to be met for us to know for sure that something is a rhombus or a rectangle. One way we already know is the definitions, but there are some theorems as well, and this is one of them. If the diagonal of bisects angles, then it's a rhombus. Okay, so looking at this one, just to make my life a little bit easier, we'll put those numbers in. So we're going to say that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. We just do that because it's kind of the obvious thing to do here, but based on the given. And so that's just definition of angle bisector. Now, the other thing that we know, and so to do this, and there's a couple different ways you can do it. Actually, probably the easiest way to do it is to go ahead and show that BD is congruent to BD by the reflexive property, which that gives us enough to show that AB triangle ABD is congruent to triangle because we know that this angle is congruent to this angle and this angle is congruent to this angle, right? So ABD is going to be congruent to CBD. And that is going to be because of angle side angle, right? We found the two angles and then the side in between them are all congruent. And then from there, there are some various ways that you could finish this, but this is enough because this gives us by CPCTC that AB is congruent to BC. Right now, the only way we know to prove something's a rhombus is by definition, which is to show the four sides are congruent to each other. And so that would then tell us that we know BC is congruent to AD, and AB is congruent to CD, and that's because of the in a parallelogram, opposite sides are congruent. And then the final thing is just using some transitive property. We'll just put them all together. We know that ABC is congruent to AB is congruent to BC, is congruent to AD, is congruent to CD. And that's just applying the transitive property. And then from there, that tells us that ABCD is a rhombus. And that's entirely by the definition of a rhombus. The reason we know it's a rhombus is because we showed that all four sides are congruent to each other. All right, the second theorem from this section, 6.1-13, if the diagonals of a parallelogram are perpendicular to each other, then the parallelogram is a rhombus. I think we're going to go by and not prove this one. And so because it's a pretty simple one to prove, what this is saying is if we have a parallelogram and we know that the diagonals are perpendicular, which means we know that this angle is congruent to this angle, is congruent to this angle, is congruent to this angle. We need to prove that this is a rhombus. Well, all you end up doing is similar to what we did when we proved converse of this, you're going to show that AE is congruent to itself, ED is congruent to EB, and then because they're perpendicular to each other, then these angles are right angles, which means they're congruent to each other. So by side angle side, you could show that AED is congruent to AEB, which would be enough to show that AD is congruent to AB, which means that all four sides are going to be congruent. Interestingly, I just thought of another way that you could have done this. AC, in the case of a rhombus, because we know it's a parallelogram, we know that the diagonals bisect each other. And we just showed, we were given that they're also perpendicular, which means AC is a perpendicular bisector. And the perpendicular bisector theorem says any point on the perpendicular bisector, in this case A, is equidistant from the endpoint. So we could have shown that AD is congruent to AB using that perpendicular bisector theorem. All right, last theorem from this section, 614. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So we've got two diagonals drawn into our rectangle. And you're given that they are congruent to each other. And so you're given that A, B, C, oh, this is a parallelogram. So A, B, C, D is a parallelogram. And you're given that AC is congruent to BD. The diagonals of a parallelogram are congruent. So AC, and if this is a parallelogram, AC is congruent to BD. And then we want to show that this is a rectangle, which means we're going to need to show these are right angles. And we can do that by proving these two triangles congruent. Again, we know that AD is congruent to BC because opposite sides of a parallelogram are congruent. And then we also know that DC is congruent to itself by the reflexive property. Which then says that triangle ADC is congruent to triangle BCD by side, 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 right? This is congruent to this. The diagonals are congruent. DC is congruent to itself. From there, we can say that angle ADC is congruent to BCD. And that is because of CPCTC. And then we also know that ADC and BCD are supplementary. We know this because consecutive angles in a parallelogram are always supplementary. And then finally, if we know if two angles are congruent and supplementary, then they are right angles. And so we can say that angle ADC and angle BCD are right angles, which is going to be enough by definition. So this was the reason if two angles are congruent and supplementary, then they're right. And so for this problem, we've shown that these are right angles. And we did this again in a general way. We could do the exact same procedure to show that AB or angle A and angle B are right angles. And so from that, we would know enough by definition to say that ABCD is a rectangle. So if diagonals are congruent, we know it's a rectangle. If diagonals are perpendicular, we know it's a rhombus. And if the diagonals bisects the angle, we also know that it's